So this next section is something that's pretty cool. It has really opened up a huge industry within our practice of security, and that's threat modeling. Really, there's a number of different ways that we could go about doing threat modeling. Typically, the top two ways that we see out there is just like healthcare, proactive or reactive. So proactive threat modeling, it's baked in, where essentially we go out there and we try to predict the threats to our resources or assets. And then reactive is we're throwing on the red hat, or the red team, the black hat, where we're a bad guy, and when we're going in and actually looking at it, we can use ethical hacking, pen testing, source code review, and fuzz testing. When we look at these right here, there's a couple of things that we'll talk about later in a later domain, but I want to bring them up here, so if you hear them twice, it'll probably stick with you a little bit better. So source code review typically is, there's two types of source code review. There's static source code analysis, which means basically, it's a regular expression grep search for bad stuff. So what does that mean? That means that you give me your code, and my analysis will look at keywords in the source code. That's all this fancy stuff means, the regular expression grep search, right? I just give it a bunch of keywords that are known to have nefarious functions, and then from that, the static source code analyzer will find a bunch of stuff. Another one is the dynamic source code analysis. The software is at runtime. So the software builds, you're able to build the software, and then at runtime, you do a dynamic analysis to see where you can poke holes into that dynamic analysis. These tools are not cheap either. Anybody that does those two types of analysis knows what I'm talking about. Like Fortify is one tool, IBM AppScan, Code Sonar, some of the Carnegie Mellon stuff, the SEI like Rose or Lint or Splint, open source. Yaska is a good one, yet another source code analyzer. So there's a bunch of different tools that you can use to put you in a position where you can have reactive threat modeling using source code analysis. One of them here that you may see on the exam is called fuzz testing, or a fuzz analysis. And this fuzz analysis is literally you try everything that you can possibly think of. Typically, we say that we throw the kitchen sink at it. So anything that your team can come up with, anything that you can come up with, you're going to try to break that application or get it to behave in a way that it was not intended to. In football, whether it's pro, college, or even Pee Wee, Pop Warner football, typically they say one of the coolest things is to make somebody go somewhere that they don't want to be, or somewhere on the field where they don't want to be. So if you're blocking somebody, you can move them. If you're strong enough or you have good balance, you can move them to somewhere where they don't want to be. They're trying to get somewhere, and you can move them somewhere they don't want to be. Well, essentially, fuzz testing is similar to that, where we're throwing everything that we can possibly throw at that to make the application behave in a way that it was not wanting to be, right? That it was not intended to be. And there's a bunch of different techniques for that, but at a high level, you can bolt on these solutions. Usually these solutions are 10 times more costly when you bolt on the solution. 10 times more costly. Whereas if you bake it in, you get into the cyclic approach of maybe a 15-day sprint or scrum through agile development, and you're baking it in. As you move to the SDLC, a lot of times the threat modeling can maneuver with the project and streamline security much differently than if you bolt it on at the end. That's why typically this is much more cost effective, the threat modeling. So there's a few different techniques. Microsoft came up with one, and they call it the STRIDE method. That's spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And so you would identify threats based off of this acronym and then label it accordingly. In addition to this model that Microsoft developed, the STRIDE model, there's another one that's called the PASTA method, And so that is the process for attack simulation and threat analysis. Just like you would imagine for the DoD and really anybody who's got way too much time on their hands coming up with acronyms, they come up the acronym first and then shoehorn in the something sexy for the actual words that make up the acronym. But this one's kind of neat. It goes through and talks about the different phases or stages here over on the right hand side. You can see this different stages. There's in this particular case, there's 7 steps or stages, and I have those listed right here, and some of the more granular components within those stages here for doing this threat modeling is shown over on the right hand side. But one of the things that is kind of neat, and I can't believe that I'm actually saying these two words right next to each other, but Microsoft actually has this free tool. I can't believe I'm saying that, free and Microsoft together. That's called the Microsoft Threat Modeling Tool. And so this is a free downloadable tool that Microsoft puts together. And if we go in and just create a model, let's just take a look at this real quick. This will not actually be on the exam. The Microsoft Threat Modeling Tool will not be on the exam. But I just want to show you here, right? Let's say you have a, you know what? Let's go with MySQL. We put MySQL here. We have a web application. Okay, so we have Azure web application. And then I want to throw, I just throw a trust boundary around this. Okay. And then, so I got a request. So there'll be a request coming from the web application to the Azure database, and then there'll be a response, just like a normal web service. Okay. So check it out. And then I have a browser over here. So user would use browser. Browser would request from the web application. Right? The web application would then respond to the browser. Like that. And it snaps in here. And I can go in here and label each one of these, like specifically for my web browser. I can go over here with these elements. And again, this won't be on the test. I'm just showing you for practical purposes. So I have this baseline, minimum standard for threat modeling here that I'm interested in. And now I want to actually do the threat model. So check this out here. If I do a full report, it'll give me the possible mitigations and the software development lifecycle phase. I can come in here and generate this report. Check this out. This is kind of neat. And based off of the report that I'm going to generate, I'm just going to say CISSP threat modeling report. It'll create an HTML file that, without me even giving any devil in the detail here, spending time on it, it'll go through and it'll show me specifics for this web application. So it breaks down the diagram a little bit. It tells me an adversary can gain unauthorized access to the Azure MySQL database instances due to weak network security configuration. And then it comes down here. Well, what can you do? Restrict access. Thank you. So then it says the same thing again. Both of these are high priorities. And this enforced communication over TLS, SSL. That makes sense, right? Adversary can, what was the difference between those two? So this one says may read and tamper. This one says gain unauthorized access. Adversary can gain long-term persistent access to compromise a local user password. That would be not good. Is recommended to rotate account passwords or secrets in Azure Key Vault is important. And so you can see that, with little to no effort in building together this network topology diagram or this application topology diagram, it immediately gave me 15 different things that I need to take a look-see at with the intent that I go in and try to fix those before that application gets launched. So again, this is a free tool by Microsoft that you might want to take a look at using that STRIDE methodology: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. I would say you will have one question either on STRIDE or PASTA, so keep that in mind.